slide shows you the summary of step 2, one journal paper in preparation. Up to now, we have been discussing how to generate soil profile and simulate the entire rainfall slide. In step 3, we want to highlight the other challenge. So how can we enhance the design and performance of this system, early warning system, using these proposed computational tools? Before going into detail this steps, let's have a quick summary here. From development in step 1 and 2 presented earlier, now we can start from borehole data. We can generate the soil profile, we input into computational model to make prediction, and thus we can do the early warning. Now in step 3, we want to develop another tool to make a quick prediction, and the model can optimize itself based on the monitoring data feedback. So this steps including 2 steps. Step 1, we generate a large data set of simulated data, and the step 2, we train machine learning model and prediction. So here we want to achieve 2 goals. First is risk mapping, and second is rapid prediction. So here to detail the step 1, a large data set are generated including soil profile and simulation outputs. So here the detail of step 2, this slide is showing you that overall procedure of our proposed framework. So firstly, we begin with the satellite or field monitoring data and a clustering algorithm is then applied to establish a risk map, which can help us to identify which is the danger zones within the safe zones. And then based on this result, we generate a large amount of simulated data of the danger slope to train the machine learning model. So after machine learning model is trained, we use it in the practice as a surrogate model. And this model allows us for rapid prediction based on any given input. So this is the entire picture of our proposed machine learning framework. Because we have 2 goals, so we need 2 methodologies. The first methodology is the clustering technique. We're using the k-means algorithm, which can group and label data pattern that share similar properties. For example, we begin with this mountain area. It's showing us that a lot of data points, and including position and displacement, and then we input the information into machine learning model. After that, this model will identify different groups. However, clustering technique doesn't explain what each group meaning, so that's what we're doing here. We link each group with their displacement information to identify the danger zone. So here's the model performance. On the left-hand side, we show the available monitoring data at the location. In the middle, we present the ground truth observation at the white area, and on the right side, you can see the machine learning model's prediction. So as the time progresses, the displacement increase. The color here will changing from blue to red, and at the same time, the clustering technique that you see on the right and also updates dynamically over time. The red color is represent for high warning zone, the yellow indicate medium warning, and the blue represent for low warning. You can see that the model successfully capture the high risk zones at each time step, providing valuable information for mitigation planning and also the dangerous location for training machine learning model. The second methodology is online machine learning. So basically, we're using the sequential architecture built from long short-term memory layer followed by a dense neural network layer. So this model is well suited for capturing the long-term dependencies in time series data. So after training on simulated data, the model used as a surrogate model. This surrogate model enables to make a rapid prediction for any given input. And at the same time, the model can update itself by minimizing the prediction errors using the real-time feedback. So here's the model performance. On the left side, we show you the ground truth observation. On the right side, we show you the machine learning prediction. The 3 points on the slope surface are selected and displayed in the center for direct comparison. The blue line represents for ground truth, and the red line is represent for machine learning prediction. So as you can see that the model continuously uses the past monitoring data to forecast the future behavior, which is the red line. The results are very nice that is showing us we're able to capture the onset of failure, which allow for effective early warning. This is a summary of step 3, one journal paper in preparation. Thesis structure. This is my 3 main chapter in my thesis, which is corresponding to 3 stages I presented earlier. This is the timeline, this is the work that I have done, this is the time that I can have left. Acknowledgement, I would like to take this opportunity to thank my supervisor, Professor Habui, for his endless support during weekly meeting. Also, weekends, he tried to help me. And also thank you, Professor Malak and Professor Yang, for helping me for my first publication. I would like to special thank to Dr. Smith, Dr. Lian, Dr. Tang for work very close with the project. Thank you, MCG Labs members, my family, best friend that always support me during my PhD journey. Thank you, panel member, Professor Chen Chang, Professor Senathan Kurikara, Professor Ashley Hacker, for spending your valuable time for coming today. Thanks.
All right, excellent. So